Hey everyone, and welcome. Today, we're going to level up your Python skills with a feature that makes your functions way, way more powerful. We're going to teach them how to talk back, how to actually give you answers. So let's get right into it and give our code a voice. I mean, think about it. You write a function to do something awesome, right? Maybe it calculates a random number or checks if your player character hit a wall. But how do you get that information, that result, back to the rest of your program? How does the function actually tell you what it found out? And this isn't some abstract idea. It's something you run into constantly when you're coding. Let's walk through a super common scenario you'll probably face when building pretty much any interactive program. Okay, so picture this. You've got your on-mouse press function all set up. Every single time you click the mouse, it's ready to draw a circle. Simple enough. But you want each circle to be a different random color. The problem is the on-mouse press function has no idea how to do that. It needs to ask for help. It needs an answer to the question, hey, what color should I use for this circle? Well, the solution is actually really simple and elegant. We're going to build what's called a helper function just for this job. And we're going to use one of the most important keywords in all of Python, return. This little word is literally the mechanism that lets a function send an answer back to whatever part of the code called it. So let's build this thing, step by step. First, we define our function, getRandomColor. Inside, we make a quick list of colors we like. Then we use the choice function to randomly pick one. But here, this last line, this is the whole point, return color. That is the command that says, okay, I'm done, here's the answer you asked for. Without that line, the function does all the work but keeps the result to itself. And the difference is like night and day. When you use return, your program works perfectly. Every click, you get a new colored circle. But without it, the function runs, finds nothing to send back, and so it returns a special Python value called none. And what happens when you try to fill a circle with none? You get, well, nothing. An empty circle. Mission failed. Now, you might be thinking, hey, couldn't I just cram all that color-choosing code inside my on-mouse press function? And yeah, you absolutely could. But creating a separate helper function that returns a value is a pro move. It gives you some serious advantages and is a key part of writing smart, clean code. For sure, it makes your code cleaner and easier to read. But the real superpowers you unlock here are code reuse and making changes a breeze. You write the logic for getting a color once, and then you can call it from anywhere in your program. And if you ever want to change how it works, you only have to edit it in one single place. Let's put that to the test. Let's say we're bored with our 5 basic colors. We want to upgrade and use the RGB function to get access to like over 16 million colors. Instead of hunting through our entire program for every place we make a color, we just go to our one helper function, random color, swap out the logic, and return the new RGB value. And that's it. Every single part of our program that uses this function is instantly upgraded. And this is just a perfect example of reusing code. Our on-mouse press function is still calling getRandomColor to make circles. But now we can add a totally new feature, an on-key press event that changes the star's color every time you hit a key. Does it need its own logic? Nope. It just calls the exact same getRandomColor function. We wrote the code once, and now we're using it in 2 completely different places. That's working smarter, not harder. So, functions can return simple things like a color string, but they can do so much more. They can answer more complicated questions, they can return decisions, and they can even return entire complex shapes. Let's check that out. First, a super quick detour to talk about Booleans. A Boolean is just about the simplest answer you can get. It's either true or it's false, a yes or a no. That's it. And this is perfect for functions that need to make a decision. Take a look at this function, isNearCenter. Its entire job in life is to answer one simple yes or no question. Is this coordinate near the center of the screen? If the distance is close enough, it returns true. If it's too far away, it returns false. Now the main part of our code can just ask that simple question and get a clear, direct answer to act on. And here is a golden rule you absolutely have to remember about return. The moment a function hits a return statement, it's done. It immediately sends back that value and stops everything else it was doing. So in our isNearCenter function, if that if statement is true, it returns true and the function just ends. It never even looks at the else part. Okay, this is where it gets really, really cool. A function doesn't have to return a simple string or a number or even a true or false. It can build and return an entire complex object, like a circle or a label from your program. Check out this getLabel function. When you press a key, it jumps into action. It loops through a whole group of labels on the screen, looking for one that matches the key you pressed. The instant it finds a match, bam, it immediately returns that specific label object and stops looking. And if it goes through the entire list and finds nothing, it returns none, which tells our program, sorry, couldn't find what you were looking for. So, you see, mastering the return statement isn't just about learning a new keyword. It's really about changing how you think about building programs. It's about creating your own set of smart, reusable tools instead of just writing one giant, long list of commands. So what's the big takeaway here? The return statement is what gives your functions a voice. It lets them answer questions. It helps you keep your code clean and organized, following that don't repeat yourself principle. And really, it lets you build your own library of flexible, powerful tools you can use over and over again. It's the key to writing smarter, not harder. By learning how to make functions that talk back, you've really unlocked a whole new level of coding. You can now build components that find things, make decisions, and calculate values for you. So start thinking about your own projects. What's a calculation you keep doing over and over? What's a piece of information you always need to find? That's the perfect candidate for your next helper function. So, what question will you teach your code to answer next?